Thank you. Very warm welcome. My name is Robert Heinze. One slide to introduce myself. I work with Relux as CTO, and I'm also a member of several committees for standard that deal with standards. For example, I would like to bridge the gap between BIM and lighting in general. This is and standards in terms of lighting. This is a lot of fun, actually, if you look into detail with lighting standards. And I'm also a member of the BIM working group of the ZVE. I'm not only dealing with lighting or light, but also with product declarations, product details. My topic today is digital light design. BIM, what does that mean? It is about digitization of the construction industry. I switched to a data model, which is great for everyone who likes to work with digital media, with programs for lighting design. So you get a digital a version of your building, which can be enriched with data throughout the design process. And the great thing about BIM or digital buildings is that you can map or show all the different stages, all the different phases, not only lighting, concrete, but all trades can be mapped in one data model. So this is the change that BIM brings about. It is shifting or turning away from paper towards a digital model of your building. So the design process includes many people normally, and they can interact or collaborate with each other in a much better way, or much easier. So this is the theory behind it, but practical examples have shown that it actually works. Communication stays the same. BIM is not something that replaces communication between people. We need to talk about the plan, the design in general, but we've got more sophisticated tools for the design process than we had 20 years ago. This is how a BIM process works. There are several standards that describe a BIM process. ISO 19650, for example, and this is the last standard that I would like to mention. But for those of you who want to take a deep dive, feel free to have a look at this standard, because this describes the BIM processes. The great thing about the processes for the entire design process, not only for lighting design, is that at a very early stage, you have to design the entire design process. This is called EER, Exchange Information Requirement. This is what it's called in English. And this is something where you have to deal with from scratch at the very beginning of a project. You have to talk about this with your clients, with your customers. What do we want to do? What kind of software are we using? What kind of data format? What are the tasks of the individual trades? And at a very early stage of the design process, this is what has to happen. So you have to think about this, talk about this from a theoretical point of view, but this is part of the practical work today. New structures, IFC, for example, is an important data or file format in the lighting area. We've got GLDF. It's an open file format. Everybody can use it. Everybody can write it and read it. This is a file format from Velux and DL and Relux, where we describe lights digitally. We create a digital twin of lights and sensors. GLDF has already gone live, and it's been published a couple of years ago already, and the GLDF IO. And they can also read it today. The systems that are used today can already read it. You only need to generate one data set per lamp as a manufacturer. So this is a great development. It actually works. And it's great to see that it works. So this gives us the opportunity for a structured data exchange for lights. For lighting. Lighting is not everything when it comes to a building, but it's one important factor for our industry, of course. Then we deal a lot with renovations at European level. We've got so many old buildings here that we need to renovate, and you should use the structure of the building, the main structure of the building. I was a bit skeptical about that. So I wanted to find a way how to use your existing model and use it in your BIM model, in your authoring system. How can you do that? Do you have to scan the room with your mobile phone, or how does it work? But there are telephone scan apps, mobile phone scan apps that can really scan the entire room already. So we work with AI systems like the one you can see here from enriched, which is a young company from Austria. And they developed a tool using AI pipelines to generate a structural model like you want to have it in your BIM model. So it is not individual vectors. It is just walls, windows, doors, chairs, tables as individual data objects. So it generates individual 3D objects of tables and of chairs that you can use as a light designer. So it's not. You can just, for example, have a look at all the chairs. You can delete them. You can touch them. You can have a look at all the windows, change the properties. And this is a new way of working, which makes your work or the design work pretty easy, pretty simple. And it works better every day. This is what I wanted to show you. What about BIM lighting design? What about digital lighting design? Using a digital data set of a building. We've got different input opportunities on how to generate a data model. IFC, for example, is a great data exchange format which is open and free to use for everybody. This is a great progress, but IFC is limited, has some limits because it's a hierarchy without a fixed authoring system. So you don't have a subordinate program, but all the other programs can use it alike. So for Light, for example, you've got 48 characteristics, you got a certain photometry, but you only get 48 characteristics in the IFC. A Light has up to 500 characteristics or properties to describe it. IFC has some minor gaps or defects that can be compensated with other systems, for example. And we started in the lighting design with BIM model, for example, using an authoring system like Revit. We took the data model and transferred it to Relux and our other lighting calculation programs. So the BIM model is transferred to the BIM software that you are using or that we are using, so you don't have to copy the model again. And this is a huge relief for all the expert planners, for all the designers. You don't have to copy the model. There are 20 to 30% that saves you 20 to 30% of work as a designer that you actually spend in remodeling the building. So I've got a good friend who works in the field of structural design, and he has to remodel the entire model, structural software and static software. So he has to remodel the entire building, and this takes up 20 to 30% of his work. So with BIM, you already got the building. You can just export it to Relux, and then you've got the building with all the components that you are interested in. So this is a huge advantage. And also the way it also works the other way around. You can export it from your design program to the authoring system, and then just add the lights, and then you end up with your result, and it's integrated in your building model. And it's been working pretty well for years already. This is every part of your everyday life. This is our practical use cases. This is state-of-the-art technology, and it works. What's next? What we have further developed at Relux is the following. So we ask ourselves, why do you have to jump back and forth from authoring software to a lighting calculation program? So especially for electrical, it would be much easier if they could do their lighting design and authoring system, for example, in Revit. So we developed a plug-in including all the task areas and measuring points, a grid that you can define. You've got overview of the room. You've got an efficiency method that you can use to select the right quantities. So everything that you can do in a lighting design program can be done in a BIM authoring system, as you can see here with Revit. So it works pretty well. We've got emergency lighting calculation. So if you're familiar with Revit and the authoring system in general, if you have your model there, you can continue with your design in there. So if you are not familiar with the lighting design, this might be interesting for you as well. For example, for electricians or something that have to deal with lighting design once a year. So they don't have to use two different programs, and they don't have to jump back and forth between Revit and Relux, for example. They can do it all in one system, in one software. So this is just one option on how to integrate that. But it depends on what you want to do, or what system you're using. If you don't have Revit, if you don't have any Revit models, then it doesn't make sense to just set up a Revit model for lighting design. So this has to do with communication, interaction between the different trades. So they have to work hand in hand throughout the entire design process. So if you start as an electrician, setting up a Revit model, a BIM model, just to do your lighting design, then this means more effort for you than just replacing in your standard lighting design program, just using a standard lighting design program. But this is growing. More and more BIM models are available, also from renovations or from existing buildings, old buildings. And this is the way forward. This is an easy way to exchange data between the trades. Next logic step following digitization is automation. So if you got everything in digital version, your building, your lights, if you got the tools, the next step would be automation. So it is kind of so you just push a button and then you get all the characteristics, all the features, all the properties from the system. So, and if you then realize that it's not compatible with the standard, because this is something that you have to check as a human being, like ticking a box or something like that, or if you realize that something's in the red and you need to add another light, you need to change the type of light, you need to adjust your grid, your measuring grid to make it work. So you just have to make sure that you complete several loops before you got a finished lighting design. Well, as human beings, we are pretty good at it. We don't take a look at all the characteristics or at the best product, the most suitable product, but automation is a very good way to ensure this. Relux published a product for street lighting. This is a bit simpler from a mathematical point of view because you only calculate the direct share, and this is relatively simple. Take into account distances. You can do this based on an Excel file, for example, and the results are identical because mathematically, it's pretty simple. And for street lighting, you only take into account the direct share. And here we've got a product where you just have a website, or you can visit a website as a designer, and then you enter a road name for whether you talk about a cycle path, or you enter the width of the road, of the street. So you do a model of the road, entering several values, and then you have to enter the standard that you have to comply with. And it immediately tells you the ideal lighting situation or lighting for this street, or ideal lamp for that street. So you don't have to play around, don't have to do a lot of testing. The program does the work for you. It tests thousands of lamps, opens up a huge table in the background. This is a pretty fast process. And in the middle, you get the best top 5 solutions for your respective road with the 5 most suitable lamps for that respective road. So you can adjust a lot when it comes to street lightings. You can adjust the lenses, the light flows. You've got numerous photometric properties, different flows and streams that you can use, and these tools help you finding the best suitable lamp or lighting system for your road. Then you have to select the best one amongst the top 5 results, mast distance or clearances between the masts and so on, and you get a photometric proof with all the colors, TE values, and so on and so forth. You can print it easily, and then you're done with your lighting design. So with a small online process, it works very well for street lights. What we are doing at Relux in our labs, we do the same for interior lighting. We developed a product that automatically does the same, does the positioning of the lights within a room. We've got an AI module. Well, this should actually be a video, but it doesn't work, obviously. It looks a bit boring. But we've got a module that scans a room and equips it or positions hundreds of lights in that room. The quantities and the positions are optimized. And then you get a list of results with all the lights that that are not compliant with this standard. There are some lights that work, hundreds of lights that work for this room, and hundreds of lights that don't work. So you get a table, you get a list of lights, and then now I can select the most efficient ones. For example, you can sort them, you can filter them, and you can take the ones that are the most suitable from a quality perspective. You can filter them by certain characteristics or certain features to really find the most efficient or glare-free solution for you, for your room. And you immediately got the photometric proof for this that you can print right away. So it's also possible for indoor lighting design, and this makes our lives much easier. It's just for standard applications, for standard design processes, so for ideal light situations. So it only works for standard designs. I have to make this clear again. Next example that also works with a great data model. So if you get more and more data from the buildings, from the furniture that's in the building, you can use the data to visualize them, to visualize the building. So for Relux, we call it real-time rendering. Others might call it differently. But this is a module that we built on our own with Enscape, which is a small company from Karlsruhe, based in Karlsruhe, and they are specialized in BIM models, constructive models that don't look much pretty. They don't look really pretty. So there are no wallpapers, for example, or no surfaces, no finishes, no finishing touches displayed in the BIM models. It is not a visualization model. It's just a model that is used for design process, like a CAD drawing. But no wallpapers are included or no colors are included. It's just about the technical properties. And companies like Enscape from Karlsruhe specialized in making these BIM models look more beautiful with very simple tools. By just a push of a button, you can visualize that. And it's a great thing to do. I brought you a video, but unfortunately it doesn't work. So I wanted to show you how the CAD sketch, how the CAD drawing is visualized in that BIM model with this Enscape module. So you can really walk through it, and it looks like taken from a BIM engine. You can walk through it, and all the renderings, you get all the renderings in real time, right in front of your eye. You can do your own design, position your lights visually with a real-time rendering. You can just walk through the model, you can experience them, you can have a look at all the rooms, and this is the next level. And it works pretty well with more data. So with furniture, you can visually, not photorealistic, it looks like a video game actually. You can just walk through the room and see what happens if you sit here. What does it look like if you sit here in this corner? Here you've got a glare effect. Here you are dazzled. This in this corner, I want a different color here. And as a designer, you can really see the room from a different perspective than it would be possible with a CAD drawing. So this is what we get here. If we got more digital data in the planning phase, on the design phase. So this brings me to the end of my presentation. I've got 30 seconds left because the videos didn't work, but maybe we got some questions. Thank you.